Now we're going to start building out the cryptocurrency exchange smart contract. We're going to create a new contract here in this contracts directory. I'm going to create a new file here just called exchange. All right, so capital E exchange.sol. This is our new smart contract for the exchange. So really briefly, I'm going to describe the behavior of this exchange and what it's going to do, all right? It's going to be a smart contract that's going to handle all of the behavior of our decentralized exchange, okay? So what can they do with this exchange? Well, it will deposit and withdraw funds. All right, they can manage orders. They can make orders or cancel them. And they can also fill orders. Well, let's just say it'll do trades. And this will charge fees. All right, so this is sort of the high-level overview of what the exchange actually needs to do. All right, and I'm actually going to break all these things out into a to-do list for development like this. I'll just paste this in here. All right, so these are all the things we actually need our smart contract to do. So think about it from the perspective of using an exchange, right? So the exchange is basically going to handle all the user funds, right? And it's going to manage the orders, and it's going to make trades, all right? So inside of here, think about it from a use case perspective. You're going to deposit Ether into an exchange if you want to buy tokens, all right? So you would deposit Ether. You would make an order, so you'd make an order, and then that order would get filled, right? And then whenever it's done, you would withdraw your tokens. Or sorry, withdraw tokens right here. Or opposite, you could, deposit tokens and make an order, and the order could get filled, and then you would withdraw Ether, right? Because you got Ether back if you came with tokens. And you could do any combination of those steps. In the middle, you could cancel your order, and you could also see your balance on the exchange after you've deposited Ether or after you've deposited tokens. You'll see, how many, tokens are on the exchange and not in your wallet anymore, okay? And at any time, you can, withdraw that from the exchange. You don't have to keep them on there. So this is basically going to be our checklist that we're going to implement when we build the smart contract. And also, I should say, with filling orders, we want to charge fees. So basically, we want to develop this smart contract in a way that anytime a trade is made, we as the developers will get a small fee of every single trade. And I'll show you how to do that whenever we build this out, okay? And we'll collect the fees from this. So I guess there may be a couple of things with this. Whenever we, deploy the smart contract, we want to set the fee. All right, so we'll determine some sort of percentage that gets set whenever we deploy the smart contract, and we'll also set the account. Whenever we deploy the smart contract, we'll tell it where the fee goes. All right. So that's our to-do list, and we'll do this one by one. First, we will declare the version of the Solidity programming language, just like we did in the token. Let's say pragma Solidity. Say caret. Say version 0.5.0. All right. And we're going to create our exchange contract. We'll say contract exchange. All right. And the first thing we'll do is set this item in our to-do list. We want to set the fee account. This is going to be the account where the fees go whenever trades are issued. Okay. So let's implement that, and let's write a test for it. So we'll go to the token test, and I'm going to create a new test file for the exchange. And here's the new exchange test. This will be exchange.test.js. And I'm just going to paste in what we did for the token just to get us started. All right, we're not going to use all of this. I just want to use this as some boilerplate code. So I'm going to minimize this and take out all these extra examples. Basically, I just want to describe the deployment, just like we did in the last test. We're going to use kind of a basic pattern here. All right. So instead of token, we're going to do exchange here. All right. So we're still going to import these helpers because we're going to use them. We're going to use tokens. We're going to use EVM revert. We're going to import the exchange here. All right, we want to use chai. Contract, let's do exchange. And here we'll say deployer. And, initially we want to check this fee account. This is the first step. All right. So I'm going to say fee account. All right. All right, now I'm going to take out all this configuration for the token. All right, and instead of token, we want to say exchange equals, exchange dot new. All right. So here, what we want to do is actually assign the fee account and check that it was set whenever we deployed it. So let's create a test for that. We'll say it tracks the fee account. And what we want to do is say const result equals await exchange fee account. We'll say result should equal, let's say, fee account, which we will use here. All right, so this is going to be the second account in our list. If you remember with Ganache, we have multiple accounts. Here's the first account that deployed the smart contract. This is going to be our fee account in this case. Okay, so what we're going to do is actually set the fee account whenever we deploy the smart contract. Okay, so we're going to pass it in as an argument to the exchange contract. And we can do that upon deployment like this. We can just say fee account. All right. And what that is going to pass that as an argument to the smart contracts constructor, which I'll show you here in a second. All right. So let's implement that. Let's go over here to our exchange smart contract and let's create a new constructor, just like we did in the token. We use this constructor special function name. Say constructor. And then we say address, fee account. All right, we'll say public. All right, and here, let's actually set the fee account. In order to do that, we want a state variable for the smart contract. We'll go ahead and create some variables up here. And we'll say address, public, fee account. We'll just say the account that receives exchange fees. Okay. So this is going to be a state variable inside Solidity. It's going to have a reader function that comes for free whenever we declare it public. And we can just set it inside the constructor like this. We just say fee account, fee account. All right, so I don't know if I explained this yet, but this is a local variable in Solidity with an underscore, and this is the state variable. This is basically just a convention to avoid the naming conflicts. So I think I mentioned that in the intro to Solidity, or intro to smart contracts video, but I wanted to reiterate that here. All right. All right, so let's just try to run the test and see what happens. All right, it worked. So we can see that it ran all of our tests, and we can see the exchange account here. Sorry, the exchange tests here and the token tests. So we can also basically just run the test for this specific file like this. We could just say truffle test, and we can specify the file we want to test. We can just say test exchange.test.js. So when we run this, it shouldn't run the test for the tokens. It should only run the test for the exchange. And we'll see that happen right now. All right, there we go. So the first example for the exchange worked. So now, in addition to the fee account, we want to set the a fee amount. So this will be the actual percentage that the exchange is going to charge. And just for easy math, I'm going to say 10%, okay? I know that's extremely high for exchange fees, but just so that it's easy to use math in our tests, I'm going to do 10%. If you want to deploy this for your project, you can set the fee to whatever you want to. But I'm going to make things easy on us. So I'll say uint 256 public fee percent. Say fee percentage. All right, and we're going to pass this in here as well. We'll just say uint, fee percent equals fee percent. Okay, now I'm going to do the same thing here. So instead of tracks the fee amount, we'll say fee percent. Fee, I'm just going to do all this at once. And we need to define a fee percent. Let's just do it here. We'll say const fee percent equals 10. All right. And we're going to pass that in here. And run the test and see what happens. All right, so we got a failure. It's trying to compare a big number with an integer. So let's actually convert these to strings. Say result, and then also fee percent to string. All right, save it, run it again. All right, it passed. So we're charging a 10% fee. Like I said, it's high, but it's going to make our math a lot easier whenever we're calculating fees in the test and stuff like that. So all right, that's step one is done. Set the fee account. All right, so I'm going to X that off of our list. All right, and actually I'm going to put this at the top of the file to make it a little clearer. All right, now we want to actually allow people to deposit funds onto the exchange. And I know that we want to deposit Ether and tokens, so it's two different things. I'm going to start with tokens because it's going to be slightly easier, and then we'll move to Ether. Okay, so let's actually, we won't necessarily do everything in this list in order. I'm just going to kind of approach them to what I think makes sense for the development lifecycle. Okay, so let's actually deposit tokens. And we're going to use the token that we created here. For deposits. So what we're going to do, we'll need to import that token. So we can import it from our current directory like this. So say import /token.sol. All right, and that'll make this token come into the file. All right, now that we've imported that token, we can create a function to deposit it. And I should notice that this is going to work for any ERC20 token. Any ERC20 token that follows this standard is going to be able to use this, okay? And so what I'll do is create a new function like this. We'll say function deposit token. All right, that's going to accept some arguments. We'll call it public. We'll just sketch this out. So there are a few things we need to do inside of here. We need to tell it where the token is, so which token. All right, I'm going to add some space. Which token, like I said, this could be any ERC20 token, so which one are we wanting to deposit? How much? All right, we'd answer a few more questions like, well, those are the two questions. Now we need to actually track the balance of the exchange. So internally, we need to see how many tokens you deposited it and actually, manage the deposits. Let's just say manage deposit. And we need to send tokens to this contract. All right, and I'll explain how that works in a second. So this is basically the order we'll accomplish this in. We also want to tell, external consumers this happens, so we're going to emit an event. So first we need to tell the smart contract which token. All right, we'll do that like this. We'll say address token. All right, this is going to tell us the address of the actual token we want to deposit on Ethereum. All right, so any ERC20 token, we could pass in, this address and say which token and then do it that way. Okay. So then we'll say uint amount. All right, we'll accept this. All right, so that tells us how much and which token. All right, so now let's actually focus on sending tokens to this smart contract, okay? And we'll do that like this. Here's why we need the token. So we imported the token like this, and we're going to tell it where it is. So we can get a copy of the token in Solidity like this. Say token, and then pass in this address token. All right, this is going to be an instance basically of this token on the Ethereum network. And now we can call all the smart contract functions that exist on this token, right? Specifically, we're going to call the transfer from function. So token transfer from, okay, and then msg.sender, and then we're going to say this. So this in Solidity just means this smart contract. So this exchange smart contract is going to represent this. And this is actually going to be an address. So I'm going to wrap it in address like this. All right. And then finally, we need an amount. Say amount. Okay. So remember, our transfer from function is going to allow the exchange to actually move tokens to itself. And in order to call this function, we're going to have to approve the exchange to do this. And we'll do that in our tests, and we'll do it in our client-side application, which you'll see later. Okay. So token transfer from msg.sender to this smart contract and this amount. And that's what you're doing here. So you must approve the tokens before you can call this function, all right, which we'll see. All right. So now let's just write a test for this. Let's go to our test file here, and we're going to say, so describe deployment. Let's just copy this and describe depositing tokens. All right. So we're going to do what we did in the last test, where we say describe success. Sorry. And we're also going to describe failure. So we want, the happy path and also any failure cases. All right, so let's just work on success first before we handle the failure cases. When we deposit tokens, we want to say, it tracks the token deposit. All right, and I'll say async, pass it a function. All right, so inside of here, what we're going to do is basically check that the token balance was updated to this smart contract. All right, so there's a few things we need to do. First, we need a copy of the token inside of our test. We'll do that like this. Copy, exchange, token. All right, and we're going to need to deploy the token just like we did in the token test. All right, we'll say token, let's just say, do this. I'm just going to copy it. So this is, we'll do the token first. And also up here, we'll say let token. All right, so let token, let exchange. We deploy the token, we deploy the exchange. We've got all these files inside here. All right, so what we're going to do now is set this up. We're going to have to approve these tokens before we can call this deposit function, because, like I said, you're letting this token, or you're letting the smart contract, the exchange smart contract, transfer tokens on your behalf. So remember, when we implemented that, we must approve them first. Okay. So let's do that in the test. Say describe, or sorry, let's see before each, and then we'll pass this async function. Formatting, and inside of here I'm going to say await token.approve exchange address. All right, so this is the exchange here. We can get the address and pass that in as the approval address is the spender, right? And we want to approve a certain amount, so we'll just say tokens. We'll do 10 tokens for now. Say from, and let's pass in a new account. So I'm going to set up some users here for the exchange. We'll just call this user 1 for now. This is in the accounts list, all right? And this will correspond to this account in Ganache. All right, so that'll be our first step. We need to approve the exchange to move tokens for us. And then we'll call the deposit function. So just as always, we're going to say let result, and we'll say const result equals await exchange deposit token, and we'll pass in token.address. We'll say tokens 10, and then we'll say from user 1. And then also we need to add user 1 here. All right, so that should be exactly what we need. We can approve the tokens, deposit them. And once the deposit has happened, we actually want to check the token balance. All right, so let's do that like this. We'll say const token. Let's do it this way. Let's say let balance. Balance equals await token balance of, let's say exchange address, and then we'll say balance toString should equal, say tokens 10, let's say toString. And let's make that the amount. Refactor this. So instead of saying tokens 10 all the time, let's just do amount. All right. That reduces duplication and makes things a little simpler. All right, so I'm going to save this, and let's run the test, see what happens. All right, so we got an error. I think I know what's happened. I think that the user 1 who tried to approve the tokens hasn't actually got any tokens to approve. So let's go transfer some to them. Let's do that in here. We'll say exchange, let's say a token transfer. Say to user 1. Let's say tokens. Let's give them 100 tokens. Say from deployer, because remember that's who has all the tokens whenever this token gets deployed to the blockchain. So I'm going to do that above here. So let's make some comments. Say deploy token, and let's transfer some tokens to user 1, and let's say deploy exchange. All right, let's run the test again, see what happens. All right, they pass. So we can see that the token deposit actually worked. So we transferred tokens, and we check that balance from the token itself. All right, let's update a couple things inside of here. Let's go back to our exchange. And now what I want to do is basically make sure that this worked. So we always want to issue a require statement for this. I'm going to say require this. All right. So basically, this is going to return a truthy value, and if it does, we want the function to continue execution, and if not, we want it to fail. We don't want anything else to happen if this transfer doesn't occur. So let's run the test again. All right, so it passes. So let's see what else we want to do. So we've sent tokens to this contract, so we'll remove that. And now we want to actually manage deposits, okay? So we don't want to simply use the token to determine how many tokens are on the exchange. We want to use some sort of internal tracking mechanism to determine how many tokens have been deposited, which token has been deposited, and who they belong to. All right, so we're going to do that internally inside of our smart contract with a tokens mapping. All right, just like we did in the token with the balances mapping, we're going to create basically a similar kind of concept inside of our exchange. Okay, and so we're going to call this mapping tokens. So we'll say mapping, and this will be address. We'll fill this in a second. Public tokens. So it's actually going to look kind of like this 2D mapping where we had allowances, where we have a mapping inside of a mapping. In fact, I'm just going to copy this in here and replace it. Say this tokens, because it's going to work basically the same way. yeah, it's almost the exact same. I'm basically going to keep a mapping of all the tokens that have been deposited. That's going to be the first key, the token address. All right. Then the second key is going to be the address of the user who has deposited the tokens themselves. All right. And then that's going to show all their balances. So the first key is going to be the token, right? It's called a tokens mapping. So first key is a token. Second key is the actual user address. And then the final value is the actual number of tokens held by the user, based on the token. So we want to use that as an internal check. So let's actually update that like this. So basically say tokens and token. So this is going to be the token address. And we want to say msg.sender. And here we basically just want to add the amount. Okay, and we don't want to just add the arbitrary amount that comes in. We want to actually update the amount if any exists. So we do that like this. Basically, we say tokens equals token msg.sender and then add amount. Okay, does that make sense? So I'll pull this over so you can see it all in one place. So basically, take the tokens mapping, pass in the token address, which comes in here, pass in the user address who's depositing tokens from msg.sender, and just update it. So if something exists already, add the current amount that's coming in. And by default, this is going to be 0 if there are no tokens in the mapping. All right, now we can check for that in the test. Basically, we want to say, balance at this point. We want to check the token balance, not just the balance from the exchange, the balance of the token on the exchange rather than the balance on the token smart contract. So balance equals weight. This would be exchange. Tokens, token address. And then we're going to pass in the user. All right, so it's going to get the actual balance of this token for user 1. And here we want to say, basically balance toString is just basically run the same thing again. Balance toString should equal the amount here to string. All right, so let's save that, run the test. All right, so we ran into another issue. This is a compilation issue. This is saying add doesn't exist. And we saw this in the last section where we developed our ERC20 token. Can you remember what it is? Well, we're missing the safe math library. So if you remember in token, we imported this. Just going to copy it. Remember, we're using safe math for, safe math, just like it sounds like, basically to prevent integer overflows and stuff like that. So at the very top of our smart contract, I'm going to paste this in as well from the token. Basically, we're using safe math for uint. Now that's going to give us the add function. Save that and run the test again. All right, it passes. And now I'll make a comment here. I'll say check tokens on exchange. Okay. All right, so that takes care of managing the deposits. We've updated the balance. Now we want to emit an event, just like we said here. Let's emit a deposit event. Okay, and let's give it some arguments. We'll say token, that'll be the address. And we'll say who it came from, msg.sender. And we'll give the amount. And finally, we'll give it the current balance, which at this point, we'll just read the balance like this. Copy this and paste it here. All right. So that emits the event with the arguments you want. Now we actually need to define the event, all right, which we'll do up here. We did that inside of the token. Let's do it inside the exchange. So we'll say events. And now what we'll do is say, we'll use the event keyword. We'll say event deposit. All right, and we'll give it the arguments. We'll say address, token, address, user, uint 256, amount, and then uint 256, balance. So I'll drag that over so you can see all that. So we created a deposit event with the token, the user, the amount, and the balance. All right, let's just run the test without creating a test for the event, just to make sure it worked. All right, let's do that first. All right, so we got a compilation error. It looks like it's missing a semicolon, which it is. I'll put one in here. Rerun the test. All right, the test still passed. So let's actually test for the event. Now you've seen me do this a few times now. I'll open the token.test.js. We checked for the event, several times in the token test. So I'm just going to copy this and paste it into the Exchange. You could certainly refactor this if you wanted to create your own kind of helper that checks for events. I'll leave that to you as an exercise. But for now, I'm just going to kind of get you rolling with this. This will be, emits a deposit event. So instead of transfer, we'll say deposit. And the arguments are going to be a few more. So let's look at what they are. Be a token, user, amount, and balance. All right, so let's see here. Event from, say token. All right, and that's what it should look like. So you can see the token should have the right address. It should have the correct user address, the token address, user address, the amount, and the balance. And that's how we fetch all of them, just like this. Okay. You can pause the video if you want to and take a look at that. Okay, so let's run the test. And I'm trying to save you some time at this point. We're going long. This is really in depth. I want to try to reuse anything that we can and not belabor the fact that I've showed you how to create this event several times. I got a little issue here in my JavaScript for the test. Looks like I'm saying const result here when I really want to say result because we already declared it here with let. All right, so let's do that. All right, it worked. So we're getting pretty close to finishing our deposit tokens function. All right, next what we want to do is actually handle any failure cases that might come up. So let's try to transfer tokens if there's no tokens approved. So I'm going to paste this example like this. All right, so when no tokens are approved, we want, so I'll create more space. We want it to fail, right? So we want to try to deposit tokens without approving them first from this user. And if they haven't happened, then we're going to reject it. All right, so let's actually take this before each for the token approval, and let's put it inside of the success function. Okay. So we only want this run for successful cases. For non-successful cases, we don't want to approve it first. We just want to try to transfer the token. Put it in there. All right. So let's do that. Run the test. All right, it works. All right, now our deposit token function is almost complete. There's going to be one more thing we want to check for. Basically, we just don't want someone to try to deposit Ether with this function, but I'll show you that in a minute. We'll say don't allow Ether deposits. Just going to create a to-do item. Do, all right. And then also for these failure cases, we're going to do a to-do as well. We're basically going to say it rejects Ether deposits. All right, and we'll say async to-do fill me in. All right, so we're going to come back to this in a minute. So next, I actually want to implement the ability to deposit Ether, and then we'll come back and check for this to make sure that you can't deposit Ether with these functions. All right, now we're going to let you deposit Ether into the Exchange. We're going to create the ability to do that. So I'll create a new function here. Say function deposit Ether. All right, it's also going to be public. Oops, sorry. And inside this function, we're basically going to do just about what we did inside of here, right? With a few differences. For one, we don't have, Ether's not a token, so we're not going to have to, import the token and transfer it. But we are going to have to tell our Exchange, how much Ether each person has, right? We're going to tell it that a deposit event happened, okay? And also, we need to send Ether to the Exchange, right? We need to keep track of a balance, kind of like we did with the tokens. So first, what we're going to do is actually keep track of the amount of Ether inside the tokens mapping. All right, now that feels a little strange at first, but it's going to make things easier because it's going to reduce the amount of storage on the blockchain. That's going to be something that you're always worried about is, how much storage are you using? So we're going to keep tokens in the same mapping as Ether and vice versa. Okay. So how do we do that? Ether doesn't have an address. Well, we're basically just going to create one for this purpose. All right. And we're just going to say that, the Ether address is just a blank address. So anything that has a blank address inside of here, we're going to assume is Ether. That's going to be kind of like our Ether token. You can think about it that way. It's not actually going to be a token. It's just going to be a placeholder. And we'll say this, address constant. All right. It's going to be Ether equals address 0. All right. So this allows us to store Ether and tokens mapping with blank address. All right, I'll pull this out so you can see it. So Ether, all right, const Ether, address 0. And now what we can do is anytime someone comes in here, we can actually store the amount of Ether they send like this. Ether from msg.sender equals, the actual amount that's being sent in. All right. So how do we get an amount, right? How do you send Ether inside this function? Like, how do you pass Ether into a function argument? How does that work? Well, you don't do it that way with Solidity. Solidity allows you to send Ethereum cryptocurrency or Ether with any function call, actually. So if you see this function metadata over here, from, this accepts, several different keywords, from. It also accepts something called value. All right. So value is actually the amount of Ether that we can send with the function. So we can read the amount of Ether that's sent with the function with the MSG global variable, just like msg.sender. All right. And what we can do is say add msg.value. All right. So msg.sender is the person who's sending the function, and msg.value is the amount of Ether that's getting sent with the function. That's how you pass Ether into this function, essentially. All right. And in order to make that work inside Solidity, you need an additional modifier. It's called payable. So in order for a function to accept Ether with metadata, it has to be considered payable because there's no payable modifier. All right. You got to have this payable modifier in order for it to work. All right, and I'm going to go ahead and finish building out this function. It'll be complete. We'll just go ahead and emit a deposit event, just like we did inside the deposit token. So emit deposit, this will be token. In this case, it's going to be Ether. Say msg.sender. Instead of amount, it will be msg value. And then we'll say tokens, Ether, be msg.sender for the balance. Okay, so that's all we have to do to deposit Ether. We did a lot of the hard work with deposit tokens. Now, if you remember, inside of deposit token, we wanted to say we don't want to allow any Ether deposits. All right, so we'll go ahead and do that like this. We'll basically create a require function that will check to see if it is the Ether address. All right, so they don't want the token basically to be Ether. We don't want that to be the case. All right, so now we can write a test for that. That's what I said we're going to do, a to-do item here. Basically, we'll say await exchange, so deposit token, and then we'll pass in the Ether address. So address 0 basically is going to look like this. All right, and then we'll say tokens 10. We'll say from user 1, and basically this should be rejected with the revert message. All right, so let's run the test and see what happens. All right, so it looks like we had a compilation issue. I forgot to change this, so instead of Ether and then token, we want Ether and Ether. All right, so that'll work. Let's try to run the test again. All right, it passes. So let's actually refactor this a little bit. We're going to use this over and over again. So we're just going to call this, I'm going to copy this and call it Ether address. And we're going to define this inside of our helpers file. So helpers ether.js. We're going to export a new constant. Export const ether address equals that. All right, then we're going to import that inside of our exchange, ether address. And let's run the test again. All right, it passes. Okay, so we've finished our to-do items for the deposit token function. Now let's get back to depositing ether. Let's actually write some tests to ensure that it works the way we expect. So here's depositing tokens. Let's create a new describe function for depositing ether. I'm just going to minimize this, deposit tokens, and let's try the test above it because I'm going to keep this in order. So deposit ether, deposit tokens. I know we wrote the tokens first, but let's just keep our tests in the same order as the functions. We'll say describe. Let's say depositing ether. We'll say async. Okay, so create some space here just so we can read it easier. All right, now inside of here, I'm going to say let result. Just like we did in our other examples, I'm going to use a before each hook again. Say before each, pass in a function. Oops. And inside of here, we're going to deposit the ether. Say result equals await exchange deposit ether. All right, we're going to pass in some metadata. All right, so remember I said you can't pass in ether as a, it's like you can't pass it in as an argument. You actually have to pass it in as function metadata. Since it's payable, we can do that. So say from, say user1, and we'll say value is the amount of ether we want to deposit. So what we want to do is actually deposit 1 ether. Now remember, just like tokens, ether is expressed in way with smart contracts. It's a decimal resolution, which is 18 decimal places. That's in way. So what we can do is say basically, web3.utils, two-way, ... right? That looks really familiar to our helper, right? That we defined inside this helpers file. So if we go to our helpers file, remember we were converting, we want to say 100 tokens and get that in the decimal resolution. We can do the same thing for ether. So we could just refactor this and, call this ether, it'd be the same thing. And we could also just say export const tokens, is equal to ether. So same as ether. So I'm making ether the reference point because I want people to understand that tokens work the same way ether does. All right, so let's just save that, and we'll just import that into our file, ether. And we'll say value, we want to do, I'll say 1 ether. All right, and we'll actually call this amount. Say let amount is this. All right, and now let's check the transfer. We'll test for the balance to see that the transfer actually worked. So I say it tracks the ether deposit. Pass in a function. And we'll say const balance equals await exchange dot tokens. And we're going to fetch the token. We'll say ether address. Remember, we're storing this ether address inside this mapping with the ether address constant. And we're going to say user1. So that'll be the balance. And the balance toString should equal amount toString. All right, let's run the test and see what happens. All right, it worked. So now let's also make sure that this deposit event is triggered. We'll basically just copy this. We'll say it emits a deposit event. I'm just going to copy this and put it in here. Like I said, you could write yourself a function that removes this duplication if you wanted to. I could certainly leave that up to you as an exercise. But this will just get you rolling and make sure that it works. So let's run the function again. And this actually might need to change. I think I need to update. Yeah, this shouldn't be the token address. This should be the ether address. All right. Ether address. This should be tokens 10. It should be ether. Oh, let's just say amount. I should probably refactor that in the other one too. Amount. All right, yeah, so I expected that to happen. So let's actually refactor the other one while we're here as well. So we'll go down to tokens, and instead of tokens 10, let's use amount. All right, save this, run the test. All right, it passes. So we've tested for that deposit event whenever we add ether to the exchange, and it works. All right, so now we've checked a lot of items off our list. We've deposited tokens, we've deposited ether. Okay, now I want to do one more thing while we're here that's not really included on this list, but it's basically a safeguard. Okay, what we want to do is make sure that people can't just send ether to this smart contract by itself. We want them to deposit ether with this function, but we don't want them to just send ether to the smart contract itself because there's no way for them to withdraw it. Like, we don't want them to copy this exchange address and put it in their MetaMask wallet and hit send, right? We want to issue a refund if that happens because that's faulty behavior. We can't actually send ether back to them with the smart contract. So you'll see this happen a lot. It's a good practice to have on your smart contracts to have a fallback function. Basically, if someone tries to send ether to your smart contract, just refund them, right? That's the best practice. So I'll show you how to do that. Let's write the test first. So I'm just going to copy and paste an example here. So right after deployment, let's minimize all this. And we're going to describe fallback. And I'll show you this. So basically, we want it to revert if ether is sent. So we can send ether to the exchange directly like this. We can just say exchange send transaction. It's going to send a basic Ethereum transaction. And we can say any amount. This could be, ether 1, or it could just be one way. It doesn't really matter. So we say from user 1, and it should always be rejected. All right, so if we run it now, it should fail in the sense that we are accepting this, but we want the opposite behavior. We want it to send a refund anytime someone tries to send ether to the smart contract. So let's actually implement that behavior inside the smart contract. So I'll do that like this. Basically, you can create a fallback function, say function, and then with no name, say external. All right, say revert. So this will be fallback. Reverts if ether is sent directly to this exchange. Okay, so we want to do that. All right, now let's run the test and see what happens. All right, it passes. All right, so that's everything in this video. We have, set the fee account. We've deposited ether. We deposited tokens. We've done a lot, even though we've only written a little bit of code. There's a lot more to do here, and in the next videos, we're going to, withdraw ether, withdraw tokens, allow people to check their balances, make orders, cancel orders, fill orders, and charge fees. So yeah, there's a lot to do, but whenever you've completed it all, you're going to be a really strong blockchain developer that understands how this works. So I'll catch you in the next video.